Yes, welcome again to Intermediate Macroeconomics. So this is DC Economics, and we are going to look on how we can solve the rotate maximization by using the Langrarian formula. Now, for example, the production functions of a product is given by Q bracket, then capital and labor is equal to 100 KL. If the price of capital is 120 Tanzania shillings millions per day and the price of labor is 30 Tanzania shillings millions per day, what is the minimum cost of producing 1,000 units of output? Now for that case, we are provided with ints, citing up the Langrarian formula. That is C is equal to WL plus RK. Now this is subject to the constraint, that is Q KL is equal to 1,000, and so for the capital and labor in terms of Cobb-Douglas utility function, that is the CO. Now from this question, now we are required to solve out what is the minimum function, what is the minimum cost of producing 1,000 units of output, and then we solve for the capital and labor in terms of Cobb-Douglas utility function. So actually required to solve the Cobb-Douglas function, solving out the capital and labor as you observe. Third one is to write the Langrarian to minimize the cost, that is equal to WL plus RK subject to the constraint, that is output, that function of capital and labor, that is equal to 1,000. And to part B now, suppose we have a production function that is given as a function of capital and labor, that is equal to KL. The price of capital is 10 Tanzania shillings millions and the price of labor is 15 millions. Now, what combination of labor and capital maximize output given a fixed cost of CO, that is Cobb-Douglas utility function? Now, for that case, we are given up the ints that we set up the Langrarian to maximize the output, that is capital and labor, to subject to the constraint, that is WL plus RK, which is equal to CO. Now let's go to the solution now. How can we tackle this kind of question? As we provide the int set up the Langrarian formula that will maximize the output subject to the constraint, that is WL plus RK, which is equal to CO. Now let's go to solution. Question number 1, we are given the output, that is capital and labor, which is equal to 100 KL. The output is 100 and C is equal to WL plus RK. The price of capital given is 120 Tanzania shillings and the price of labor is 30 Tanzania shillings. Now you're required to solve out the minimum function, the minimum cost of producing 1,000 of output. Now the solution, by applying out the formula for Langrarian formula, that is equal to L is equal to U plus lambda times budget constraint, whereby our C represents of the budget constraint, that is equal to 1,000. The budget constraint is equal to 1,000 minus 30L minus 120K. Now suppose we have the utility function that is equal to KL, that is equal to 1,000 KLQ. The Langrarian formula we plug in, the Langrarian formula plus lambda times budget line. So we take out the budget line, we insert to the equation, and we times lambda to the equations. We derive the dl in respect of dk, and also in respect of l, and then in respect of d lambda. So you obtain the equation 1 and equation 2 as you observe. Now for that case, now we take out equation 1 and equation 2. Then we equate out the two equations and finding and let out the lambda equation. So when we take out from this formula, now we take out the dl over dk, which is equal to 0. We take 100k minus 120 lambda is equal to 0. We take out negative 120 lambda is equal to 0 minus 100k. So we divide by a negative 120 both sides. You obtain the lambda equation 1, that is equal to 5 over 6k. That is equation 1. We come up, we take out from equation 2 of dl, which is equal to 0. We equate out and so make out the lambda the subject. We divide by 30 both sides. Our lambda for equation 2 will be equals to lambda, which is equal to 10 over 3 L. So that will be the equation 2 for lambda. Now after solving that, now we equate out the two equations for lambda. We equate out the two equations for lambda. Now this will give us lambda is equal to lambda, and then we take out the 5/6 over L, that is equal to 10/3k. We divide by 5/6 both sides. We'll obtain our L, which is equal to 4k. Now from this 4k we plug into the budget constraint, so as we can obtain the lead value of k and L. We take out 1000 minus 30L minus 21k, which is equal to 0. We plug in our 4k on L and we'll obtain out the values of k. So divide by negative 240 both sides, you'll obtain out k, which is equal to 4.16 or 25/6 when we put it in fraction form. Now for that case, now we substitute our k, which is equal to 4.16, to L, which is equal to 4k. When we plug in exactly, we'll obtain the value of L, which is equal to 50/3. So this will be our L. So these are the bundles that we obtain to minimize cost of production of 1000 output, that is k is equal to 25/6 and L, which is equal to 50/3. So these are the two equations that gives us the result of k and L. Now let's come to another part, that is solving the utility by Cobb-Douglas utility function. We can apply in solving out the utility by Cobb-Douglas utility function, where we have our data set such that we are provided with output of capital and labor that is equal to 1000 KL. Our Q is equal to 1000. We take out from 1000 is equal to 30L plus 120K. The price of capital is given 120 and PL is equal to 30. So from Cobb-Douglas utility function, marginal utility of K over PK is equal to marginal utility of Y over PY. We differentiate marginal utility of capital, we obtain 100,000 L. Marginal utility of L, we gives us 100K. So we take out this formula, we plug into the Cobb-Douglas utility function. This will give us 100L over 120 is equal to 100K over 30. So when we make some multiplication over there, we obtain 100L times 30 is equal to 120 minus 20 minus 100K. From that formula now we are capable of solving out the capital and labor, as you can observe. So this will give us 1 over 100 over 1 over 20 is equal to 30 over 100K divided by 100 and 120. So since here we make out to divide by 100 over 120 both sides, so as we can equate to find out the values of L, which will give you is equal to 4K. Now we take our L, which is 4K, we plug it to the budget constraint to obtain the values of K and L. So the answer will give us 30, we plug in 4K plus 120K. We take out 1000 is equal to 120K plus 120K. We divide by 240 both sides, you obtain the values of K is equal to 4.16. It will bring the same result, the same answer as we did from Langrarian formula. Now we substitute our K to obtain the L. To the equation of L is equal to 4K. We plug in 25/6 to that function, to that equation. The answer will give you out 50/3 or 16.66. So the values of K and L by use Cobb-Douglas function will give you is equal to 4.2 and 17. So that is how actually we plug in the questions. Thank you. Welcome to DC Economics. Bye bye.